All right, so you should have worked on your warm-up with a partner. Um, we're just going to talk about it real quick. Um, on the first thing that you probably noticed is that the tables are swapped. Your x's and your y's are flipped. You might have also noticed that the graphs are reflections of each other. So if we took it across this line that goes through the middle, y equals x, that is a reflection across that line, right? It mirrors itself. Okay, and then to sum that up, to just put those two together, they are inverses of each other. So y equals 3 to the power of x and y equals log base 3 of x. Those are inverses, which we already knew. We talked about how exponential versus logarithmic are inverses. They are opposite. They undo each other. So today, we are actually going to use that knowledge to graph logarithmic functions, and then we'll talk a little bit about transformations because it's been a minute, but that's really a review. So graphing, again, all this is to just say that they are inverse functions. Log base b of x and b to the power of x are inverse functions. So what you can do is you can graph by reversing coordinates of points on the graph of G. And that's exactly what we're going to do. We're going to swap our x's and y's. All right, so when we look at our first example, and this is a nice little picture to show you what it's going to look like, but let's actually work one out. So we have y equals log base 2 of x. Okay, so that is the inverse of y equals 2 to the power of x. And so we are just swapping our x's and y's for this. So when we graphed exponential functions, we said, okay, for our x values, we are going to plug in positive and negative numbers. This time, we're actually going to put those for our y values. So I'm going to count, let's do by twos. So -4, -2, 0, 2, 4. Okay, so just for logarithm, put it in the y's instead. Okay, and then we're going to plug that into the inverse function, the 2 to the x, 4x. So we're going to find 2 to the -4th power. So type that into your calculator, 2 to the -4th power, and you should get 1/16 or 0.06. Okay, and then you're going to type in -2, so 2 to the -2nd power. So that's 1/4 or 0.25. Okay, then we plug in 0, so 2 to the 0 power. We get 1. We know anything to the 0 power is 1. Then 2 to the 2nd power, we know that's 4. And then 2 to the 4th power, you might have to plug it into your calculator. I'll give you a second. We'll get 16. All right, so let's plot those points. So our first one is at 0.06, -4. So just barely moving to the right and down to -4. And this is the part where it looks really rough on my screen, so I apologize. Okay, and then 0.25, -2. So again, just barely moving over, and then at -2. Okay, 1, 0 is a little easier. So we're counting by 2, so we know that's going to be halfway between 0 and 2. Okay, and then 4, 2, so over to 4, up to 2. And then 16, 4, so over to 16, up to 4. Okay, so we will connect those dots. And for these, just like how we had the y-axis, not the y-axis, the x-axis was a horizontal asymptote. For these, the y-axis is the vertical asymptote. So it's going to get really close, which I'm actually crossing because I'm doing this on a computer screen, but it's going to get really close to the y-axis and not actually cross it. So again, on my screen it looks rough. Let me see if I can fix it. We're getting really close, not actually crossing it. There we go, that looks a little better. Okay. So again, you're just taking your inverse, so make the base of your log the base of your exponent, and swap your x's and y's. All right, so that's graphing a logarithmic function. Now the next thing that we're going to do today is we're going to talk about transformations. So the first thing we're doing is transformations of exponential. Now these are all the same as what we did every other time that we talked about transformations. It's just been a minute. So first thing that we've got going on is this right here, the horizontal translation. So that is when you've got plus or minus with your x. Okay, and remember, horizontal is opposite. So minus is right, plus is left. Okay, now vertical is when that's being added or subtracted at the end. So it's not with your x. You're not stuck with your x. And that is exactly what it is. So plus is up, minus is down. Okay, next thing is reflection. So if the negative is with the x, then that's in the y-axis, so that's your horizontal. If the negative is in the very front, that's in the x-axis, that's your vertical. Stretch and shrink. So if it is with the x, it is horizontal, and remember that's opposite. It'd be cool if I could use the little pointer. So this 2x means it's a shrink by 1/2, and then this x over 2 is a stretch by 2. So you're flipping it and you're changing what you call it. Now, if the number's in front of the base of the exponent, that's a vertical stretch or shrink. So if it's bigger than 1, it's stretch. Smaller than 1, shrink. All right, so our first example, describe the transformation of f of x equals 1/2 to the power of x, represented by g of x equals 1/2 to the power of x minus 4. So here, our difference from f to g is the minus 4. So that is outside, so it's vertical. And it's plus or minus, so it's a shift. And then minus we know is down 4. Okay, our next one. Describe the transformation of f of x equals 3 to the power of x, represented by g of x equals 3 to the power of x plus 2. So from f to g, the only difference is the plus 2. So again, that is on the outside. It's not attached to x, so we know it's vertical. It's plus or minus, so we know it's a shift. So we just have to figure out the direction. So vertical plus would be up. Okay, our next one. Describe the transformation of f of x equals 1/4 to the power of x, represented by g of x equals 1/4 to the power of x minus 2. So from f to g, the difference is the minus 2 in the exponent. So it's attached to x, so I know that's horizontal. And it's plus or minus, so it's a shift. And then minus 2, we know horizontal is opposite, so that would actually be to the right 2. All right, our next one. Describe the transformation of f of x equals 0.5 to the power of x, represented by g of x equals 0.5 to the power of x plus 1 minus 6. So Now we have two differences from F to G. We have the +1 and we have the -6. So the +1 is the first thing that we see. That's attached to the X, so that's a horizontal shift. And then horizontal's opposite, so plus, we say is to the left 1. Okay, and then the -6, that's on the outside, not attached to the X, so that's a vertical shift. And minus would be down. Okay, our next one. Describe the transformation of f of x equals 2 to the power of x, represented by g of x equals 2 to the power of x minus 3 plus 1. So from f to g, the only differences are the minus 3 and the plus 1. So minus 3 is attached to your x, so I know that's horizontal, shift, and then minus opposite is right, 3. Okay, and then the plus 1 is on the outside, so that's vertical shift. And then plus would be up. Okay, our next one. Describe the transformation of f of x equals e to the power of x, represented by g of x equals e to the power of x plus 3 plus 2. So just because the base is e doesn't mean anything is different. We're still just looking for differences. So from f to g, we now have plus 3 and we have plus 2. So plus 3 is attached to x. That's your horizontal shift. And then plus would be to the left, 3. And then your plus 2 is on the outside, so I know that's a vertical shift. And plus tells me it is going up. All right, next one. Describe the transformation of f of x equals e to the power of x, represented by g of x equals negative 1/8 e to the negative x. So we've got a couple things here. Now remember, when we talk about transformations, negatives are never attached to the number. We treat them separately. So negative and 1/8 are separate. And then we have this negative also. So negative in the front, that is not attached to vertical, or not attached to x, so that is vertical. So remember, we take our pencil, and if we were to reflect vertically, that is over the x-axis. So we're going to say reflect over x-axis. That is the first negative on the outside. Okay, now the next thing we have is a 1/8 in the front. So that's being multiplied. So that is your stretch or shrink. So on the outside, we know is vertical. And vertical just is what it is, right? Vertical does not lie. So vertical, 1/8 would be a shrink by 1/8. All right, and then the last thing we have is the negative attached to the x. So again, negative is reflection. And then since it's attached to the x, that is your horizontal. So remember, take your pencil and flip it horizontally. And we know that when we do that, we're flipping over the y-axis. Okay, our next example. Describe the transformation of f of x equals e to the power of x, represented by g of x equals e to the x plus 2 minus 1. So our differences from f to g are plus 2 and minus 1. So plus 2, it's with x, so it's horizontal, shift, and so plus 2 would be left 2. Okay, and then minus 1 is on the outside. It is not attached to x, so that's your vertical. Shift. And then minus 1 would be down 1. All right, we can also look at transformations with logs. We treat them the same way as any other transformation. So if we have plus or minus a number with the x, then that is your horizontal translation. If we have plus or minus not attached to x, so it is not in parentheses with x, then that is your vertical translation. Negative signs are your, oh, okay. I guess I can't go back, but that's okay, because it all works the same anyway. Okay, so part A, describe the transformation of f of x equals log of x, represented by g of x equals log of negative 1/2 x. So from f to g, we have a negative and we have a 1/2. So again, remember, negatives are separate from the numbers they have next to them. So that negative is a reflection, right? And since it is attached to the x, it is in the parentheses with the x. That is your horizontal. So horizontal, you flip your pencil, that's over the y-axis. All right, now 1/2, again, it's attached to x, so I know that it's horizontal. And it is being multiplied, so that is your stretch or shrink. Now horizontal, that's the tricky one because it's opposite, right? So 1/2 is actually going to be a stretch by, and we flip it. So instead of 1/2, it's 2 over 1, which is just 2. Okay, our next one. Describe the transformation of f of x equals log base 1/2 of x, represented by g of x equals 2 log base 1/2 of x plus 4. Now, the 1/2 is in both of them, so it is not a transformation. We are only looking for things that are different from f to g. So for this one, that is your 2 in front, and that is your plus 4 in the parentheses. So the 2 in front, that's being multiplied, right? And it is not attached to x, so it's vertical. Okay, and then multiplied means stretch or shrink. Vertical doesn't lie. Vertical is what it is. So 2, since it's bigger than 1, would be a stretch by 2. And then plus 4 in parentheses, so it's attached to x, so it's horizontal. Plus means it's a shift. And with horizontal, if it's plus, it's going left. 4. Okay, next example. Describe the transformation of f of x equals log base 2 of x, represented by g of x equals negative 3 times log base 2 of x. So again, that base 2 is the same on both, so it is not a transformation. So the only differences are the negative and the 3. So negative we know is reflect over, and so negative on the outside is vertical. So vertical, when you flip your pencil vertically, that is going over the x-axis. All right, and now the 3 on the outside, so it's also in the same spot, so it's still vertical. And it's being multiplied, so that's your stretch or shrink. 3 is greater than 1, so that is a stretch by 3. Okay. Last example, describe the transformation of log base 1/4 of x, represented by g of x equals log base 1/4 of 4x minus 5. So the base is 1/4, it is not a transformation. So our differences are this 4 and this minus 5. So 4x, it's inside with the x, so it's horizontal. And it is being multiplied, so that is your stretch or shrink. But remember, horizontal lies. So greater than 1 would actually be a shrink. And we flip it, so instead of 4, which is technically 4 over 1, it's going to be 1 over 4. All right, and then minus 5 on the outside. Outside is vertical, minus is shift, down 5. And that is it for 5.4. This is the last lesson that we are doing in Chapter 5. So next time we will review and we will take that quiz that we talked about last class. So please work on your practice for this. It is due at the end of class. You will turn it into the substitute. And then if you need time to finish it later, if you cannot finish it in class, take it home, work on it, and bring it back next class. And then next class, be prepared for review and a quiz.